Alrighty, time to get started. This is Chris Robinson. He is a digital technologies and maths teacher at Aberfoyle Park High School. So one of the problems that often comes up when teaching Python to students is that they just want to build apps. It turns out you can build apps in Python, and I'm very excited to hear how Chris does that. Some of his students have published apps in the App Store, so we'll find out how he's done that. Thank you, Chris.
Good afternoon, everyone. My name is Chris Robinson, and I work at Aberfoyle Park High School in South Australia. At the moment, I'm a digital technologies teacher, as well as a little bit of maths. This is a bit of my school background. I work at a government school with around 1,100 students. We're an Apple school, and our students have iPads from years 8 to 10. And when I first arrived at the school, that posed some problems with what was I going to do with them, with these iPads, when the end goal was actually having them write some code and to do some programming. So I teach digital technologies year 9 and year 10, and then IT 11 and 12, and then we're transitioning Digitech into 11 and 12 over the next couple of years. So when I started work at APHS in 2014, I wasn't teaching any IT at all. I started off just teaching maths, even though I'm trained in computer science. The job was in maths, and that's how I got in. So I decided to start off this small lunchtime group. It started off very small, maybe around 10, 15 people. And that was in 2014 when I was just teaching the maths and one class of science. And now the lunchtime group has actually grown over the years to a slightly bigger crowd, and it has a stronger focus on application development rather than just sort of text-based programs. And I didn't even think of having apps on the store at the time. And then after, I guess, the first year, I was like, yeah, why can't they publish them? And had to learn quickly how to publish an app on the store with the description and all the icons and things. So these are some of the reasons why I think Python's a really good language. I think it's awesome as a first language to start off with. It's very easy for them to learn. And yeah, you can start really easy, but you can get to quite high levels, which I love. So like I said before, these are the subjects that I teach at the moment. Year 9 digital creations, Year 10 digital creations, Stage 1 Digitech next year, and then Stage 2 in 2019. I guess my Python group has extended into the real classroom, and I get to do some of this work as a real subject, which is awesome. So now over a semester, my students would spend either 6 or 7 weeks using Python to develop applications for their iPads. And the thing I really like about it is they do all of their work on their device. They can code anywhere they like, at home, at school. All the documentation is in the app and it's offline, so they don't have to have internet access for it to work. And yeah, it's a full Python interpreter built into the app. And I like to show them some foundation stuff, whether it's like me live coding on the screen, or whether they can just watch the YouTube videos. That's something that I've started off this year. And if you want to have a look at my YouTube channel, you just have to follow me on Twitter or go onto my Twitter and go to the website link. So the idea is they work on these creations inside of the classroom and outside of the classroom, and then some of them are going to get up to the point where they can actually publish their app on the store, and some of them are just going to sort of modify a little bit of what I've done and extend on that a little bit, and some people are going to build things completely from scratch. And some people are going to go further than that and do crazy things with OpenGL shaders and put lots of physics into their work and things like that. I like to spend the classroom time that I've got with them on challenges and collaboration, because I think that's more useful than the mechanics of me doing some code and showing them some stuff. So that's why I've started a YouTube channel, so that everyone can learn in their own time. And I'm already finding that that's quite a valuable resource for them. And I'm just on my way to get 100,000 subscribers. I think I got about 30. So I'd like to tell you a little bit about the app that I've used and why I chose it. So like I said, when I started work at Aberfoyle Park High School, we weren't doing any sort of code, and I was thinking, what am I going to do on these iPads? I'm used to using computers. I've just done 3 years of Java. What am I going to do with them? And so I found Pythonista, and I haven't done Python before. I only learned it in 2014, and I'm so glad that I did, because it's so awesome. But what I love about the Pythonista app is it has a full code editor. It used to run Python 2, and now it runs Python 3. Actually, it runs both, and you can switch between whichever interpreter you want to use. And the students find it really easy to get started, whether it's doing something text-based or finding out how loops work. But quite often, I like to start off with graphics, because they can see something on the screen. And it doesn't take a great level of skill to actually put something on the screen, get it moving, and then you can extend on that. One problem that I did find that the students run into is indentation and not getting their code indented properly. So I'm trying to find a way to best manage that. And yeah, that problem quite often comes up when they try to mix spaces and tabs together. I'll quickly explain what the students learn out of doing this work with me, and then I have some student examples. So the main thing they learn is obviously problem solving. They learn a whole bunch of that, breaking down problems and coming up with the solutions to their own problems. I think it's really cool that they come up with their own problems rather than me always giving them one. I can do that in the start, but in the end, I want them to create their own problems and solve them themselves. They learn lots of coordinate geometry. So I used to teach maths a lot, and it's very important. And they're only working in 2D space, so some of them will move on to 3D afterwards, but most of my students are just working in 2D. So they need to figure out the various positions of the screen and where to place the items. They learn how to create and use objects, subclasses, callback methods, things like that. I teach a lot of frame-by-frame style animation. So yeah, you can create an action object that does like move to, and you put in the X and Y and how long you want it to take. But I would like to show them how to do frame-by-frame animation. So basically every frame nudging a sprite node to make it move. Then they can have a think about changing the speed in different ways. Like I said, with actions, I guess an action is like an animation, and they can be like move to, move by, fade to, fade by, and then you can apply them to the individual things that are on the screen. So that's something they would move into a little bit later. They also learn how to use discrete methods to handle touch events, like touch began and touch ended, and then they'll also do the other method, which is touch moved, which fires quite a lot as long as you're moving your finger over the screen. So these are the two modules that the author of Pythonista has built into the app. So they're iPad specific. One of them is the UI module, and you can put in all of Apple's native controls, text boxes, sliders, buttons, switches, all that sort of stuff. You've got view controllers you can make, and some of the students, particularly my Year 12s, have done their final projects using the UI module. The scene module is the one that I usually start with, and it's just based around a 2D scene, and you have sprite nodes, which are the objects, and then you can have some actions that are applied to those objects. And that's probably where I start. That's what all my videos are pretty much based on, and I find the students really like it. It's based on C types, and it's not quite a complete wrapper, and that's probably one of the things that I like about it. It doesn't contain For anyone that's done any other Apple development, it doesn't contain any physics body objects, so they can't just make a physics body object that's, let's say, like circular and have another thing that's circular and have them collide because they're rectangular. So they actually have to figure out some of those mathematical and physics concepts themselves. And it enables the students to practice and use their high-level math skills, such as distance between 2 points, and it makes them implement their own physics engine, which you'll see in a minute. So these are what we've got published on the store so far. We have Boxscape, Third Law, Square Blockade, Fan Run, Blockade Runner, and Combo Crush. And if you search up APHS, standing for Aberfoyle Park High School, you would find all of them on the store. So what happens with the students and making these apps, like I said before, they do all the work on the iPads, and then they basically send me their finished work, and then I drag their Python file into the template, and then add on some icons, and then submit it to Apple for testing, and then it gets published. So these are some of the things that I'd like to show you that my students have created. All right, I'll just talk about it. So this is Boxscape, and one of the really cool things that the creator of Boxscape has done, Jasper, is he's made all of these out of simple rectangles. So even the characters and things like that, even though they look pixel-based and they look like a PNG image texture, they're not. They're just, he's coded in all of them as individual rectangles, which I looked at and I was just really impressed. So basically, every time you pass 3 of these sticks, you get a new bar on the top, you get a new chunk of the bar, and then once you fill that bar, you go to the next level and things get faster. I also quite like the parallax effect that he's put with the backgrounds. You can also get some coins at various times, and then you can use those coins to unlock some other characters, including me and my girlfriend and my dog. They all had to be characters on there. And also Jasper's on there, and our science lab manager's on there as well. And there's a cat and a pirate and stuff. So this was a year 8 creation, and I think it's pretty cool that a year 8 has an app on the store. So my second one to show you is called Third Law, and I would say this one has the most advanced level of Python inside of it, only because he's using subclasses and things to create these different cannons that fire at you. And the whole idea of the game is you fire the bullets and you travel in the opposite direction to which you fire. So you basically got the joystick on the bottom left, and you travel around the screen and kill the cannons without dying. And one of the other things I really like about this is that he's created a text-based level engine. So he's put in a whole bunch of characters, and then when it's parsed using a loop, it will actually go and map out all of the different cannons, whether they're a spinning cannon or a 4-way shooter or a 2-way shooter or a 2-way shooter that's spinning. He's got different codes that represent each of those, so he can just build up his map. So he spent quite a lot of time building the engine that actually reads in these blobs of text. But then he's made 100 levels. So if you go and download this game called Third Law, coming from Newton's Third Law, then yeah, you can play 100 levels. It gets pretty hard towards the end. And there's even other students of mine that are saying, yeah, where's the next 100 levels? Which is pretty good. So this student is in year 12 at the moment, so he doesn't really have time to build another 100 levels, but I'm sure he's going to do some crazy things in Python later on. This one I have to show you is from one of my year 10 students. And basically, you just have to move up and down the screen and dodge the blocks. Sometimes you go a little bit faster, and then you can also change your colour of your block. If you don't like red, you can be green or blue or whatever. So this one is called Square Blockade, and he built the menu system from scratch, which was really impressive, and it took him quite a long while to actually figure out why the touch events were actually basically going to the underneath layer and not the menu. And so, yeah, it was really cool when he actually got that to work in the end. There's two different ways to control it. You can control it by just having the screen divided in half, and the left half of the screen goes down and the right half of the screen goes up, so you can touch the left or the right. And the other way you can play it is if you enable the buttons, then as you can see, you've got the up and down buttons on the left. This one right here is called Fan Run. And I thought it was pretty cool. There's a giant fan that's running after you, and you basically just have to jump over the gaps. So one other cool thing about this is, I guess, all of the saving of the information and things, all of the saving of the high scores and the settings and things like that is done with Pickle. So that's probably another thing that I really like about Python, is that you can just import Pickle and you can easily load and save information. Quite often they'll just be using a dictionary with various keys to store different integers. But I find it a really easy way to save high scores and other information. This game right here is called Combo Crush, and it was actually one of our first game that's been designed in portrait mode. And you basically just have to look at the colour in the top right, which at the moment says purple, and you have to swipe 3 purples. And the thing I really like about that is that he's using the 3 methods to detect touches, and that's touch began, touch moved, and touch ended. And when a touch begins, he's creating like an empty list, and then as you swipe your finger over these blocks, it adds whatever block you've swiped over to that list, and then at the end, when you release your finger, it will look over that list that it's just created and figure out if they all match that same colour. And if they all match the same colour, and that colour is still the one that's selected at the top, then you get the points. But if you happen to select like 3 reds and a purple, well, you're not getting your points for those reds because you made a mistake. It also makes a really good use of actions to animate the blocks when they disappear, and also the score number animates its way up into the top left of the screen as well. So now I'm going to show you some work that's basically a work in progress. This is some work by one of my students in Year 10, and he's basically creating a game called Attack of the Goblin Army, or Goblin Rush. And a lot of the math involved with this came out of how to get these cannons to range properly. So as these goblins walk past, if they are within range of the cannon, they will be shot. So basically what he did to fix that, or get that working, was every 1 second he's doing a check on each of the cannons, and then he's just checking to see which of the other goblins are inside of that radius. So obviously the goblins are stored within a list, and then the other characters are as well. He's looping over that list, and he's doing a math.hypot function to figure out the distance between the 2 points and if it's in range or not. And if it's in range, then it gets shot and it loses some health. This is some work that I guess showed I think a great deal of perseverance. So I guess one of the foundation things that I show my students is a game similar to this. And if you have a look on my YouTube, it's on there. He had the idea that when you collect a power-up, that you should be able to fire unlimited bullets rather than just having a few on the screen at a time. And so he wanted, whenever you collect one of the power-ups, he wanted it so that a timer was started, and then that power-up would only last for 5 seconds. And it took him a little while to figure out how he was going to start the timer, how he was going to tick the timer down, and then what to do when the timer was finished, resetting it to 0, and things like that. And then, yeah, he was really proud when he got it to work. And so was I. This is some work from one of my Year 8s, and I guess this is just to show you what some of the code looks like. This is a soccer physics game that one of my Year 8s is trying to build. And the ultimate goal that he wants to be able to do is to swipe around the screen and to move the soccer ball just by swiping it. And so at the moment, the soccer ball will bounce inside of the goals and outside of the goals. So he's got some of the bouncing things to work, but he's at the point where he's trying to get the swipes to work. And so you can see here that he's using a class, and it actually comes in a template. So you basically just have to fill in whatever method you want to use. So I'll quickly tell you the different types of methods. We have setup that happens at once when you run your code. We have update, which happens every single frame. And at the moment, all of our games run at 60 frames a second. So that method just gets run and run and run. And then you got your 3 methods that handle the touches. Touch began when you put your finger on the screen, touch ended when you take your finger off the screen, and then touch moved when you do a drag. And so all of this sort of building up code goes in the setup, and then, yeah, you just put in different bits of code in different spots. This is some work by the Year 12 that made Third Law, and it just shows some of the really advanced things that he's doing in terms of his mathematics work. So I guess this was when he was in Year 11. He did some really good mathematics work and actually submitted an assignment based on this. And he then later told me that, well, without Python and without the knowledge that I showed him and without him getting into Python, he wouldn't have been able to do work up to this standard. And I think that's really cool, because I can't take the credit for him using matplotlib or whatever, but I certainly showed him some Python and started him on the right way. So that's some of the other things that my students have been using this for, apart from games. So I don't quite understand that graph, but he does, so that's all right. So Jasper's also been working on some advanced concepts as well. He's the one that's been doing some crazy stuff with OpenGL shaders. And basically he's implementing some sine wave functions which actually involve differentiating. And he's trying to make the legs in this little scene, he's trying to make the legs actually look sort of natural. And that's the good thing about this, is that it actually doesn't contain all of the physics body stuff in it, so you can't just go away and use it. You have to actually code it yourself, which further, I guess, reinforces the physics knowledge and the mathematical knowledge. So this is what he was showing me, was like a small test of the way that different things can move. And then he was showing me what he applied it to, which is this. So basically he's moving left and right and his legs are moving the way they're meant to. This is there to show that, whatever you create on the iPad can be scaled down. And then I have one final video to show you.
An Aussie school is making a name for itself in the app world. Students from Aberfoyle Park High School have been designing and developing their own apps. Their school's even become the first in the country to be registered as a developer under its own name. Take a look.
This is my game Goblin Rush, and the aim of the game is to place cannons to shoot little green goblins as they run past.
My game is Boxscape, and the idea is to get as many points as you can. You gain points by dodging orange rectangles.
My game's name is Space Shooter. It's a game where you tilt your screen to control a spaceship and you have to shoot the asteroids.
These are just some of the games the guys from Aberfoyle Park High School have created, all thanks to coding. Twice a week, they get together at lunchtime for a special coding workshop.
We're going to have a go at detecting some collisions between the emojis and the lasers.
It's been running for 3 years.
Coding is using different letters or blocks, depending what type of code you're using to make something happen on a digital object.
It's really enjoyable. It's my first time doing it this year, and it's really something different.
Coding can be a bit hard to start off with, but it gets easier.
I'm going to stop it there because I would like some time for some questions. Thank you so much for listening to my talk. This concludes my presentation. Does anyone have any questions?
Thank you, Chris.
Thank you.
Questions? Yes.
Thank you very much for your talk. I was wondering if you could go back to the third game where there was a running boy or man.
Was it fan run?
I think so. I just want you to run it again. I was wondering about something. Yes, I'm seeing that, I think a wheel that is after the boy. I want to see what happens when he's not. Or is it a video? You see there's that wheel at the back that is running after the boy?
Oh, that's the fan.
Fan, oh, I thought it was...
Yeah, if you die, the fan comes across like that.
Yeah, but does it maybe cut him off if he stops running, or or is it just there for...
Yeah, I think it's just the fan, and it doesn't actually cut him because he falls down the...
Is he always running by default?
Yeah.
Yeah, okay.
Yeah, sorry, I probably wasn't explained. He's continuously running and you just tap to jump.
Cool.
Yeah.
There was a question down the front. This will probably be our last question.
Okay. That particular game was something I wanted to ask about also. There's a gravity built into that. Did the kids research and write their own gravity, or does that come with the...
Yes. The students have to implement their own gravity functions.
Cool. All right. I think that's all we have time for. Thank you, Chris.
Thank you. Thank you very much.